welcome to this lesson on types of chemical reactions. Okay, so in the last lesson you learned that we have chemical reactions that have reactants and products, and this time we're going to categorize into 6 different types of chemical reactions so you can go through these ones, okay? So the first type of chemical reaction that we often see is something called a synthesis reaction. And in this particular chemical reaction, we take 2 reactants and we make 1 product, okay? And it's pretty straightforward. Anytime you have 2 reactants and 1 product, we will have what's known as a synthesis reaction. And the example that I'm showing is if we take carbon and we add oxygen, we can make carbon dioxide. And this is really a very simple chemical reaction. Carbon plus oxygen makes carbon dioxide. You'll notice that I'm not including the state of the reactants and products this time, just because it kind of clutters things and makes it a little more confusing. So I'm just leaving that out. It's not like that shouldn't be or can't be there, but I'm just not putting it in for this sake. So here's our example that I've got here. So I'm highlighting what you probably need to fill in on your sheet, okay? So we have 2 reactants going to 1 product, and that is referred to as a synthesis reaction, okay? Now, the next one is the exact opposite. It's a decomposition reaction. So when something breaks apart, decomposition refers to breaking them apart, okay? So 1 reactant breaks into 2 products, okay? Makes into 2 things. And the example that I am going to have here is what we refer to as peroxide dihydrogen dioxide, breaks apart and forms water and then also gives off oxygen. And if you've actually ever used peroxide, when it bubbles and foams, the foam and bubble is actually caused by the formation of oxygen that is bubbling out of the usually wound or injury, as the peroxide is often used in that case. So 1 reactant, 2 products, okay? And in a single displacement, which is the next one, this gets a little trickier. Now we're going to start to see 2 reactants and 2 products, okay? And I'm going to go over this again and explain things, okay? In this reaction, one substance, usually a metal, takes the place of another metal which is already in an ionic bond with a non-metal or polyatomic ion, okay? So I'm going to give you an example here where aluminum is going to trade places with iron. So the iron is going to get bumped out and the aluminum is going to take its spot. So that's exactly what happens. So the aluminum now combines with the oxygen, where here the iron was combined with the oxygen, and the iron is now free to be all on his own or her own or its own, I suppose. And it's on its own. And so in this particular case, one bumps out the other. And we refer to this as a single displacement reaction. Now we'll compare that to the next one, which is referred to as a double displacement reaction, okay? So in a double displacement reaction, again, we have 2 reactants and 2 products, okay? So as soon as we have 2 reactants and 2 products, we know we can go to double displacement or single displacement. And you'll also see some other ones as we move down here, okay? And in this particular one, what we're looking for is, in this reaction, usually 2 ionic compounds trade metals and non-metals. So in this particular case, we have I'm just going to go, well, what I'll do is maybe highlight in blue our metals. So you see silver and sodium are our metals, and I'll go with purple for the non-metals, okay? So here's our purple non-metals. We have nitrate and we have chlorine. Nitrate is a non-metal polyatomic ion, and chlorine is just a non-metal. And what happens is, you'll see when we go to this equation, is that these 2 here have switched places, okay? So these 2 trade places. So now where the sodium is, we now have it combined with the nitrate, and the silver is now with the chlorine. And we refer to that as a double displacement reaction. So they basically traded partners is essentially what's happened. I mean, that's maybe the easiest way to think of it, is you have, two people showing up, two couples showing up, and they trade partners, okay? And in a sense, that's what's happening here. Silver had nitrate, now silver has chlorine. Silver had chlorine, or sodium had chlorine, sodium now has nitrate, okay? Um, if we're going to do the next type of reaction, that's four of them, is a neutralization reaction. And in a neutralization reaction, okay, we have uh, two reactants again, and two reactants. Oh, come on. My marker won't turn on for me, sorry. It's giving me a hard time. There we go. Two reactants and two products. But one of the products, always, one of the products will be water, okay? And what you'll also notice is that we always have an acid combining with a base. And so become familiar with those things in your table of commonly accepted acids. This is hydrochloric acid. You can look it up. And this is sodium hydroxide. And essentially what happens is these two guys join together, right? And it releases a hydrogen and a hydroxide, which makes water. And every time you'll have water whenever you have a neutralization reaction. And you also get, we refer to this as a salt. And NaCl is a salt, so it's table salt. But even other ones that form, we often refer to that as the salt that's being produced. So form a salt and water, okay? And the last type of reaction that we like to look at is what's referred to as a combustion reaction. Yeah, these are sometimes our most fun reactions. Combustion reactions is we have two reactants and two products. Now, the cool thing here is that almost always, well, it will always be, one of the reactants will be oxygen, okay? You cannot have one of these reactions without one of the reactions being oxygen, and you will always make carbon dioxide. That's the whole concept of combustion, is that we burn oxygen, we use oxygen, and we make carbon dioxide. What you'll also find is that the other reactant always has carbon and hydrogen to some degree in it, and then it makes carbon dioxide and water, okay? And that's just the nature of it. So it's a sort of special reaction. Carbon molecules combine with oxygen, produce carbon dioxide and water, okay? So let's look at some examples and see how we can kind of break them down and make up some things out of them, okay? So in this very first one, I right away see I have 1 going to 2, okay? I have 1 reactant going to 2 products, okay? And whenever that happens, whenever I have 1 going to 2, there's only one type of reaction, and this is a decomposition. I'll just use the letter D for decomposition, okay? It just means that we're breaking things apart. So 1 reactant, 2 products, okay? Let's go to another one, just as a random one, okay? So here I see I have a carbon substance and oxygen. And as soon as I see oxygen, I right away go, ooh, do I have combustion? And yes, I do, because I'm making carbon dioxide and I'm making water. So this would be a combustion reaction, and usually I just write the letter C for combustion, okay? Done, all done. Carbon, oxygen, carbon dioxide, and water. Okay, let's keep going down and look at a couple more. The next one here, I have sodium sulfide and hydrochloric acid, HCl, or hydrogen chloride if you wish to do that. I just know that this is hydrochloric acid. But what I see happens here is the sodium and the chlorine combine together, and the sulfur and the hydrogen combine together. So what's happening here is that we're getting 2 partners trading. And when 2 people trade, we then have what's known as a double displacement. That's that double crossover trade, okay? So we call that a double displacement. So notice how sodium is with sulfur, and then sodium becomes with chlorine, and then hydrogen was with chlorine, and now hydrogen is with sulfur, okay? Okay, moving on to the next one. Well, again, we have 2 going to 2, okay, and I'm looking for oxygen. No, I don't see it. I don't see the formation of water, so it's not a neutralization. And I'm going like, whoa, boy, this is a little bit more confusing. Well, what I have to think of is that an O and an H are combined with a hydrogen here, and all of a sudden the O and H are now combined with a potassium. And then we leave a hydrogen all by himself. So really, there's an OH that jumped from here and he went over there, and that left the hydrogen by itself. And so we refer to this as a single displacement. One person kind of grabbed the partner from the other one, okay? And that's a single displacement reaction. Okay, let's look at the next one. Just doing some random examples here, folks, right? And here we have 2 reactants going to 1 reactant. And as soon as I see that, I go, oh, we're making something new. This is what we refer to as a synthesis reaction. So we're taking water plus oxygen and we're making something called peroxide. So this is the exact opposite of what we would refer to as the decomposition, where we're breaking something down. We're actually making a new, more complex product. So this is just a synthesis. Okay, and then the last one I'm going to look at, I see right away, oh cool, look at this. I've got hydrochloric acid, I got magnesium hydroxide. They're going to combine, and I can almost guarantee them what's going to happen is the hydroxide and the hydrogen, they're going to come together and they're going to form my wonderful product of water. And the magnesium and chlorine come together to form magnesium chloride. And that will be a salt. We refer to this as a salt. And this is a neutralization reaction. So we have an acid and a base come together and it neutralizes. So we call this a neutralization. Okay, so I just went through a few examples there for you, and I'm going to leave you with a few questions to do yourself on the next page. Of course, I've indicated which ones are there. Please, feel free to watch the video again, try to grasp the concepts, but there's a dozen or so. Actually, there's 13 in here, so there's one that's going to be done at least 3 times in here, and see if you can figure out which ones are which, and we'll take them up in class when we get back. All right. Hope you enjoyed the lesson. We'll see you next time.